Hello everyone, welcome to my channel Science Learning Point. I am Dr. Aramita. Today we are going to learn something that is actually present everywhere around us, atoms and molecules. Look at your water bottle, look at your pen, look at your book, your chair, even the air around you. Have you ever thought what are these things actually made of? Everything is made from very tiny particles. These tiny particles are called atoms. And when atoms join together, they form molecules. So today we are going to enter the tiny world of atom. Let's make chemistry simple and interesting. Before we start, let's see what we are going to learn. First, we will learn how substances combine. Then we will learn about atoms and molecules. We will learn how to write chemical symbols and formulas. Then we will meet ions, which are charged particles. After that, we will learn how to calculate molecular mass and molar mass. And finally, we will learn about the mole concept and solve some numerical problems. Don't worry, we will take everything step by step with simple examples. By the end, chemistry will feel much easier. Let's start with a simple question. When two substances react, do they combine randomly? Answer is no. They follow certain rules. What type of certain rules? Scientists observe these rules and give us different laws of chemical combination. What is that law? The laws of conservation of mass tell us that mass is converted during a chemical reaction. And what is the law of constant proportion? Law of constant proportion tell us that a pure compound always has its elements in a fixed proportion. Think about a recipe. If you want to make the same recipe every time, you need the ingredients in the correct proportion. Chemistry works in a similar organized way. Something similar happens during a chemical reaction. The atoms are rearranged to make a new substance. The total mass remains the same. So the rule is mass can neither be created nor destroyed during a chemical reaction. In our example, the reactants have a total mass of 11.3 grams and the product also have the total mass of 11.3 gram. So remember, reactant equals to product, but the total mass remain the same. Now imagine making a glass of water. Whether you take one glass of pure water or one big bottle of pure water, water always contain hydrogen and oxygen in the same proportion by mass. For example, 18 gram of water contain 2 gram of hydrogen and 16 gram of oxygen. Okay, if we take double the amount of water, both amounts also become double, but the ratio stays the same. It's like making lemonade. If you want the same taste, you need a particular proportion of lemon, water and sugar. In the same way, a pure compound has a fixed proportion of its elements. So remember, amount can change but proportion remain the same. Now let's solve one very easy problem. Hydrogen and oxygen combine in the ratio 1:8 by mass. Suppose we have 3 grams of hydrogen. How much oxygen do we need? We know 1 gram of hydrogen needs 8 gram of, so 3 gram of hydrogen need 3 into 8 equals to 24 gram oxygen. Therefore, our answer is 24 gram of oxygen. Whenever you see a question like this, don't panic, just remember the ratio. 1 becomes 3, so 8 also becomes 3 into 8 equals 24. That's it. Now let's imagine we are building a house with Lego block. A big Lego house is made from many small blocks. Dalton gave a similar idea about matter. He said that all matter is made up of tiny particles called atoms. He also said that during a chemical reaction, atoms are not simply created or destroyed, they are rearranged. He believed atoms of the same element were identical while atoms of the different elements were different. He also said atoms combine in simple whole number ratios. For example, water is H2O. That means two hydrogen atoms combine with one oxygen. So the easiest way to remember Dalton's idea is atoms are like tiny building blocks of matter. Chemical reactions simply rearrange these building blocks. Now, what is an atom? An atom is a very tiny particle of an element that takes part in a chemical reaction. We cannot see individual atoms with our eyes. Think about a tiny grain of salt. It already looks very small, but inside that tiny particle, there are still much smaller particles. Atoms are extremely tiny, but we don't think that because they are teeny, they are unimportant. Actually, atoms are the basic building block of everything around us. Your water, your pencil, your pen, your notebook, your food, the air, all are made up from atoms. So, although atoms are tiny, they are the heroes of chemistry. Now, suppose two children join hands. They are still two children, but together they form a group. Atoms can do something similar. When atoms chemically join together, they form a molecule. For example, two hydrogen atoms join together form H2, two oxygen atoms join together from O2, and two hydrogen atom and one oxygen atom join together form water H2O. So think of it in this way: atom equals to one building block and molecule equals to building block joined together. Some molecules contain the same type of atoms like O2 and other contain different type of atoms like H2O, CO2, etc. Now let's play a counting game. Look at O2. How many oxygen atoms are there? 2. So its atomicity is 2. Look at O3. There are 3 oxygen atoms. So atomicity is 3. Similarly, He helium 1 atom, O2 2 atom, O3 3 atom, P4 4 atom, S8 8 atoms. This number of atoms present in one molecule of an element is called atomicity. So the trick is very simple. Look at the formula and count the atoms. Imagine writing the word oxygen every time we want to talk about oxygen. That would be quite boring. So scientists used short symbol. Oxygen becomes O, hydrogen becomes H, carbon becomes C, aluminium becomes Al, chlorine becomes Cl, and many more. There is one important rule: the first letter must be capital. If there is a second letter, it must be small letter. For example, CO means cobalt, but capital C, capital O means something completely different when written as a chemical formula, carbon monoxide. So be careful with capital and small letters. In chemistry, even a small letter can change the meaning. Very interesting. Now we know that atoms are extremely tiny. So how can we talk about their mass? We cannot practically say this hydrogen atom weighs this many kilogram. The number would be extremely tiny. So scientists used a special unit called U, or atomic mass unit. We use carbon 12 as the reference for defining this unit. Some common values are hydrogen equals to 1 U, carbon equals to 12 U, nitrogen equals to 14 U, oxygen 16 U, sodium 23 U, chlorine 35.5 U, or atomic mass unit. These numbers are very useful. Later we will use them to calculate the mass of the molecules and compounds. So think of U as a convenient weighting unit of atoms. Now imagine I ask you, what is water made of? You could say 2 hydrogen atom and 1 oxygen atom. But writing that every time would be long. So scientists created a shortcut. We write H2O. This is called a chemical formula. A formula tells us which elements are present and how many atoms or ions are involved. For example, H2O, 2 hydrogen and 1 oxygen, CO2, 1 carbon and 2 oxygen. Chemical formulas are like short messages written in the language of chemistry. Once you learn how to read them, chemistry becomes much easier. Now let's learn how to write formulas. Suppose we want to write the formula of magnesium chloride. Magnesium has valency 2, chlorine has valency 1. Using the valencies, we get MgCl2. Why Cl2? Because 2 chlorine ions are needed to balance the charge of 1 magnesium ion. Similarly, Al2O3 for aluminium oxide and CaO for calcium oxide. So don't try to memorize every formula blindly. First look at the valencies, then write the correct ratio. Think of valency as the combining capacity of an element. Now let's imagine an atom that loses or gains electrons. It can become electrically charged. This charged particle is called an ion. There are 2 types, a positive ion called cation, for example Na+, and a negative ion called anion, for example Cl-. Here is an easy memory trick: cation positive, anion negative. Think of a battery. There is a positive side and negative side. In chemistry, ions also carry positive and negative charges. These ions can join together to make the compound. Now let's look at the number of atoms in an ion. If an ion contains only 1 atom, it is called monoatomic ion. For example, Na+, K+, Mg2+, or Cl-. But sometimes several atoms stay together as one charged groups. These are called polyatomic ions. For example, OH minus, NO3 minus, SO4 2 minus, NH4 plus, etc. Think of it and like a team. One player alone is like a monoatomic, and several players working together as one team are like a polyatomic ion. So remember, one atom, monoatomic, group of atom, polyatomic. That's it. Now let's combine ions. Here is the most important rule: the total charge must balanced. So sodium chloride Na plus Cl minus equals to NaCl. One positive balances and one negative. Now look at sodium carbonate. Sodium has a plus 3 charge, carbonate has minus 2 charge. So we need 2 sodium ions to balance. So the formula becomes Na2CO3 minus calcium hydroxide CaOH whole 2, because one calcium ion needs 2 hydroxide ions. So whenever you write a chemical formula, ask yourself, are the charged balanced? If yes, you are on the right track. Now let's calculate the mass of a molecule. Take some water. We know hydrogen equals to 1U and oxygen equals to 16U. There are 2 hydrogen atoms. So 2 into 1 plus 16 equals to 18U. Therefore, the molecular mass of water is 18U, atomic mass unit. So now let's take sodium chloride, NaCl. Sodium is 23U, chlorine is 35.5U. So 23 plus 33.5 equals to 58.5U. For ionic compounds, we call this the formula unit mass. So remember, molecule, molecular mass, and ionic compound, formula unit mass. Now let's understand molar mass. Suppose you go to a shop to buy rice. Okay, the shopkeeper don't count every grain of rice. He simply weighs it. In chemistry, we also need a practical way to deal with huge number of atoms and molecules. The mass of 1 mole of a substance is called molar mass. The unit is gram per mole. For example, HCl has 1 plus 35.5 equals 36.5 gram per mole. So, the molar mass helps us connect the tiny world of atom and molecules with the amount of substance we can actually measure in the laboratory. Now comes a very important word, mole. You already know the word dozen. If I say 1 dozen egg, you immediately know that it means 12 egg. Similarly, in chemistry, we use the word mole for a huge number of tiny particles. 1 mole contains 6.022 into 10 to the power 23 particles. Always remember, this number is very important. This is called Avogadro's number. Why such a huge number? Because atoms and molecules are extremely tiny. We cannot count them one by one. So instead of saying I have this many trillion particles, we simply say I have 1 mole. So remember, 1 dozen means 12. Similarly, 1 mole means 6.022 into 10 to the power 23. This is very important. Always remember the number. Now we have some very useful formulas. The first one is n equals to small m by capital M. This tells us the number of moles when we know the mass here. N equals to number of moles. Small m give mass, capital M molar mass. Another formula is small n equals to capital N by capital N A. This helps us find moles when we know the number of particles. And capital N equals to small n into Na helps us find the number of particles. The easiest way to solve the numerical is read the question, identify what is given, identify what is required and choose the correct formula. Don't be afraid of formulas. Once you understand what each symbol means, calculation become easy. Okay. Now let's solve some problems. Suppose we have 2.8 gram of irons and we want to know how many iron atoms are present. First we find the number of moles. Then we use Avogadro's number to convert moles into atoms. The answer is 3.011 into 10 to the power 22 atoms. Now another example, what is the molar mass of 0.5 mole of nitrogen? The molar mass of nitrogen is 2 into 14 equals to 28 gram per mole. So correct answer is 0.5 into 28 equals to 14 gram. Answer is 14 gram. See, once we know the steps, mole problems are not scary. Just go step by step. Now I want you to become the teacher. Try these questions yourself. First, which is heavier, 5 moles of carbon or 5 moles of sodium? Second, which contain more atoms, 100 grams of nitrogen or 100 grams of ammonia? Third, how much oxygen is needed for 3 grams of hydrogen? Fourth, what is the formula unit mass of Ca3PO4 Finally, how many moles are present in 12 gram of magnesium? So don't worry if you cannot solve them immediately. Start with what you know. Write the correct formula, put in the values, then calculate. Remember, practice makes numerical problems easy. So do more practice. Let's do a quick oral revision. What is atomicity? Atomicity is the number of atoms present in 1 mole of an element. What is the law of conservation of mass? Mass is neither created nor destroyed during a chemical reaction. Next, what is the law of constant proportion? A pure compound contains its elements in a fixed proportion by mass. What is a molecular mass? Molecular mass is the sum of the atomic mass of all the atoms in one molecule. What is 1 mole? 1 mole contains 6.022 into 10 to the power 23 particles. And here is the very important one. What's the difference between 2H and H2? 2H means 2 hydrogen atoms. H2 means 1 hydrogen molecule contain 2 hydrogen atoms. So always look carefully at the coefficient and subscript. Okay everyone, let's finish with a super fast revision. Mass, conservation of mass. Mass remain conserved during a chemical reaction. Composition, constant proportion. A pure compound has a fixed proportion of element. Atoms, Dalton theory. Matter is made from tiny particles called atom. atoms combine, molecules, atoms join together to make molecules. Charges, ion charged atoms or group are called ions. Valency, chemical formula. Valency help us write formulas correctly. Molecule, molecular mass. Add the atomic mass of the atoms. Ionic compound, formula unit of the mass. Calculate the mass of the formula unit. And finally, one molecule to 6.022 into 10 to the power 23 particles. So if you remember only one thing from today's class, remember this, don't just memorize chemistry, understand it. When you understand the concept, formulas become easier. When you practice, numericals become easier. And when you connect chemistry with everyday life, science become really interesting. Thank you for everyone. Keep learning, keep asking questions, and keep exploring science with Science Learning Point. So thanks for watching. Please like, share and subscribe to my channel Science Learning Point for more videos. Thank you. Bye bye.